So today we're going to be talking about the derivative and what it is, where it came from, and how to solve a very basic one. So a derivative is a representation of the change of a function instantaneously, which means that at one specific point, not over a distance. So let's get a little more into this. Over here we have a graph. This is just a general f of x. It doesn't really have to represent anything specific. This is just for example. Now, on f of x, I've got 2 points labeled. X, which is just a random distance that we've decided, right here. And then a distance slightly further than x, known as x plus h. Now, with any sort of average rate of change, what you'd be looking at is the change in y over the change of x along a set interval, which would be, in this case, from x to x plus h. But with a derivative, we're trying to look at it at one specific point, so we have to make that interval get smaller and smaller and smaller, which would be this part right here, x plus h. Now, if you look at this, right here, we have these 2 points, and we're going to be drawing a line between them that will represent our slope of the function. And at this point, it's called a secant, because there's 2 points of intersection along the function f of x. So here, you can see that our secant is not very close. However, if you get closer and closer and closer to f of x, like about here, you'll see that our secant is actually quite close to the slope of that line at that point, but not right there. So, how would you do this mathematically then? Well, let's go over here and figure this out. So, we're talking about the function x squared, and we're going to apply it to this formula, which can be related back to this graph. If you see, x plus h is this point right here, and then minus f of x, so it's the distance right here, divided by the distance right here. X plus h is this distance between x and h. So it's the change in y over that very small distance as h approaches 0, over the change in x, which is also going to be 0. So, let's get on to it then. You just plug in your x plus h into your original function. So we'll be looking at x plus h squared, and then you plug in x, and all over h. And you have to remember when you're doing these that the most important part about a derivative is that it's the limit as h approaches 0, so don't forget to bring that down with you. So let's do some algebra and figure this out. It's going to be x squared plus 2xh plus h squared minus x squared all over h. And then you see here these two x squareds are going to cancel each other out because one's positive and one's negative. So, moving over here, we'll have 2xh plus h squared all over h as the limit as h approaches 0. Now you might notice that we're going to run into a problem if we try to take this limit right here. Because if we try to take the limit here, we're going to have a 0 on the bottom, and anything divided by 0 is going to turn into an error. So we have to mitigate that. So we're going to factor an h out of the numerator in order to take the h out of the numerator to the denominator. So it'd be like this. It'd be 2x plus h, all multiplied by h, over h. Again, the limit as h approaches 0. So now, we have a separated h on the numerator, separated h on the denominator, so we can cancel them. They just become 1. So now we're looking at the limit as 2x of 2x plus h as h approaches 0. And I'm sorry, this is probably too small for you, so let me rewrite this. Limit h approaches 0. So now, we simply plug into 0 wherever we see an h. I mean, it's that the derivative of x squared is 2x. And that is how you calculate a very basic derivative.